What's up, everyone? My name is Joe. I'm the chief pilot and lead beta for Flysimware Simulation Software. Beautiful day out here at the airport. We're out at, this is Saratoga in upstate New York. Beautiful scenery. And really excited today to show you a little sneak into our latest project. Haven't really done a whole lot of publication with it, but you guys are going to be the first to get a look. So let's head on to the hangar and see what we have here. There's our 402. Many of you are familiar with it. One of our best-selling products in here in the hangar. The props are feathered for some reason. That's kind of weird. And the beacon's on. Oh, maybe they're doing maintenance. You never know. What else do we have here? Everybody, this is our latest production. This is the Cessna 441 Conquest 2. It's a all-metal, low-wing, all-weather, twin-turboprop cabin-class aircraft, powered by two Garrett TPE 331-10 engines. I have flown this airplane in real life. I'm a real-world pilot with experience in many different high-performance airplanes. I've flown things from Cessna 150s right up to the Lear 60. So myself and Mark Taylor, who is the lead production for Flysimware Simulation Software, have put countless hours, hundreds upon hundreds of hours into really getting this airplane right. We think you're really going to enjoy it, but I wanted to take the opportunity today just to show you guys around a little bit and give you an intro to the airplane. So we'll give you a quick walk around. Like I said, two Garrett TPE 331 engines. Now they're Honeywell TPE 331s. Garrett was bought out a number of years ago, but still commonly referred to as Garrett engines. Airplane has trailing link main gear, results in substantially smoother landings than your traditional spring oleo strut or traditional just straight shock landing gear. We have numerous animations and a lot of eye candy on the exterior here. We have inlet covers, wheel chocks, pitot tube covers. We also have in the inlet here, if you give me a minute, this is also a good time to show you our control panel. This is something that was started with, I believe the 402 was the first product we integrated this with, and it's gotten great reviews. Everybody likes it. This is one part of our control panel. Here you can control most of the animations on the aircraft, and we'll go ahead and remove them. And you can also see that is the first stage compressor turbine. The Garrett TPE 331 is a geared drive engine, unlike the more common Pratt & Whitney PT6, which you find on King Airs and the Caravan, airplanes like that. This is a geared drive engine, not a free turbine engine, meaning that the propeller is always connected to the actual jet engine via a reduction gearbox. The engine itself spins at about 15,000 RPM, whereas the reduction gearbox steps the prop down when it's at its maximum setting, which the engine itself actually runs at pretty much 100% power all the time, with the exception of start and taxi. Takeoff, landing, and flight operations, the engine is actually running at 100% of its maximum rated power, and thrust is primarily controlled by adjusting the prop pitch. So as a result, the reduction gearbox is necessary to step the RPMs down for the propeller to a mere 2,000 RPM. Very reliable engine. Not quite as popular as the Pratt & Whitney PT6A engine. The PT6 is found on quite a few more airplanes than the Garrett is. However, the many people that know both engines argue that the Garrett is a more reliable engine, and I think my personal opinion is that it's a more reliable engine, and that's reflected in its in real life in its TBO, which is its manufacturer's recommended overhaul interval. The PT6 has to be overhauled every 3,600 hours, and if under some circumstances a Garrett TPE 331 like the one that the Conquest here has can be overhauled every 7,000 hours. So it's kind of funny because the Garrett has quite a few more moving parts than the PT6 does, but it has almost twice the service interval of a PT6. So in there you can see the first stage compressor turbine right here, and that does actually, of course, you know, not to leave anything short, that is animated, does move with the propeller. What else do we have here? We'll go ahead and back up here. Yeah, when it comes to making flight sim videos, not my forte at all. But I wanted to give you guys an inside look. So I'll go ahead and put the plugs back in. That's the GPS. That's the test window. Go ahead and put the plugs back in. Gun to the wing here. I'll bring you back. Here is the engine exhaust, overwing exhaust. This is actually a huge, but the engine stops on the real airplane. The engine itself actually stops right around where these rivets stop up here, just in front of the de-ice light. And the rest of the cowling is just a long exhaust pipe that runs all the way back down. The airplane is equipped with slotted Fowler flaps, which was a little bit of a unique perspective for Cessna. Cessna, on almost all of their twin-engine piston to or propeller twin-engine airplanes, both piston and turbine, elected to use split flaps. The airplane, the twin Cessna that I own in real life, has split flaps, and everything from the Cessna 310 all the way up to the Conquest 1, which is this airplane's baby brother, so to speak, all have split flaps. They changed that with the 441 and the 404 Titan to integrate slotted Fowler flaps, as found on most jets and bigger airplanes. Much more effective. And the Conquest 2 is also the only propeller-driven twin made by Cessna that utilizes takeoff flaps as a standard procedure for all takeoff operations at any weight. So now we'll take you in, and I'll show you the cabin. Beautiful cabin we've modeled in the aircraft here. So we'll go ahead, and one thing that I insisted that we integrate just because of how much we do it in real-world operations, the cabin door is animated in two different parts. So instead of just using the Shift-E command or a click spot to open the entire cabin door, we have to open the top half of the door, and then we have to open the bottom half of the door. And the reason I wanted to integrate that, I'm a huge realism nut, and it's very common in real life if we're on a charter or dropping passengers off and then waiting for them to do their business and come back. On a hot day, it's very common that you'll see an operator will leave the top half of the door open, but we'll close the bottom half. It keeps unwanted people out of the airplane on the ramp, or better yet, it discourages people from from staying out of your airplane. But it allows fresh air to ventilate the cabin. So we'll go ahead and open the top half up, and there is the top half open, and that is normally how you'd see it out on the ramp, just like this. The airplane's not secure, but we have that bottom half closed, keeps people out of the airplane, but we still get fresh air in the cabin. So now the cabin door is open. One more thing I'll show you really quick before we head inside the airplane. We'll duck back under the wing here. One thing I was insistent on getting into this airplane, the Conquest 2 in real life has two different propeller, well, realistically 3 different propeller options. Those airplanes that have not been upgraded to the Dash 10 engines, the airplane originally had Dash 8 engines. Those that have not been upgraded, some of them are still flying around with the original factory 3-bladed Hartzell propellers. Most of the airplanes that were upgraded to Dash 10s, in fact, 99% of the Conquest 2s out there flying around today have Dash 10 conversions. It's very hard to find one that still has the original engines. Just because of the massive performance gains that the Dash 10 conversion gives you. But anyway, so most of the ones that are flying around today have 4-bladed propellers, and with that there are 2 propeller options. One of them is a Hartzell 4-bladed propeller, and the other is a Macaulay 4-bladed propeller. The Hartzell 4-bladed propeller has these big fat blades, kind of like C-130 looking props that we have on here, and the Macaulay propeller is not a scimitar blade, it's called a saber tip blade, which is kind of a predecessor to the scimitar propeller blade. And we really were having a hard time, myself and Mark, trying to decide which one we wanted to do, and then we decided, to hell with it, we'll just do both, and you have the ability, as the end user, to swap those propeller blades on the fly. So using our control window, if you look here, we can actually select between which propeller we want, whether we want the Hartzells and the Macaulays. So I'll swap over to the Macaulays just so you can see what they look like. These are the Macaulay propellers. Like I said, saber tip prop. Does not have the chord width of the Hartzell propeller. I would say the fleet right now in real world is probably split half and half between the Hartzell props and the Macaulay props. So we've given you the option to select which blade you want. The one that I have flown has these propellers, but I always kind of preferred the look of the bigger Hartzell blades. But the choice is entirely up to you. As the end user, we'll swap back to those Hartzells. So that is pretty much the external animation. I'll show you the baggage compartment up here. We also have access to the luggage compartment. This is one of the huge advantages that owners of 400 series Cessnas have from the smallest 400 series all the way up to the Conquest 2. The Conquest 2 is the epitome of the twin Cessna. This was the last thing with propellers that Cessna ever made in terms of a high-performance airplane, excluding the newer Cessna 350s and 400s. This is the epitome of of the twin Cessna. Everything that they learned from the 310, the 414, the 320, the 303, the 421, all of that culminated to produce the 441 Conquest, and it is a fantastic airplane. And one of the biggest advantages that we love as owners is this massive, massive baggage compartment up here in the nose with 3 different ways to get in. We've included the feature to turn bags on and off, just like that, so you can load your luggage up or you can have your baggage compartment empty, whatever you'd like to do. And you can also switch out pilots and co-pilots with these 2 click spots here. So you have pilot, you can see him appear up there in the cockpit. Co-pilot, you can do both of them. And of course, gotta accessorize, so you can swap a nice pair of David Clarks onto him just like that. You can also put a pair of sunglasses. I like to imagine they're Oakleys. Love Oakley sunglasses. They're just awesome. You can swap a pair of sunglasses on just like that, nice and easy. So this is the baggage compartment up here. Like I said, tons and tons and tons of room for bags up there. We love it as owners and operators. 99.9% of the trips you do, you're going to be putting all the bags in the nose, which the passengers love because they don't have to stare at their bags sitting in the cabin the entire flight. The 441 does not have wing lockers like the 402 does. I'll take you over and show you those on the 402. The 402, this is a very common piston twin Cessna thing here, are these baggage compartments in the nacelles. The 441 does not have that just due to the engine design. But like I said, plenty and ample baggage space up here in the nose. So enough out here, we'll head inside and I'll show you the cabin and take you up in the cockpit and show you what we got going on up there. If I could get the views to cooperate, that would be great. Okay, so here we are inside the cabin of the 441. I'll walk you through the cabin real quick, some of the features that we have implemented into the cabin. We opted for tan leather, and there's a couple of different cabin configurations the 441 was offered in. Most of the airplanes out there have had aftermarket interiors installed at this point anyway. But this is the basic corporate layout that you find in most of the 441s that are out there flying today. So this is a 10-seat configuration. 10 seats is pretty much the median number on the 441. They did offer a, I believe it was an 11 or a 14-seat high-density configuration for the airplane to be used as a commuter. I am only familiar with one operator in the world that uses this aircraft for airline ops. It's an outfit in Australia, I believe. They use the airplane in the Outback, and they have the airplane equipped in a high-density seating configuration. But other than them, I am not familiar with anyone that has a 441 in a commuter seat configuration. 9 to 10 seats, maybe 11, is really the highest density seating you're going to see in one of these airplanes in a corporate configuration. So we've got a 2-place bench back there. Another forward-facing seat right here by the cabin door. This is actually a potty seat in the real aircraft. The seat back folds up, the cushion slides out to the side, and there's a toilet under there. We didn't think too many of you would need to use that, so we opted not to animate it. Carpet is a nice brown carpet with a cabin runner that runs right up the center of the carpet there, as you can see. So we'll make our way a little further up here. The tray tables on both sides, you can open the cover. Go ahead and pop the tray table out. And you have a nice place to come back here and enjoy while the autopilot's flying the airplane. You can also extend the cup holders individually as well. We didn't think you'd need to use the toilet, but we figured maybe you'd want a table. Just our logic. Don't ask questions. And the same thing on the other side. This one works the exact same way. This is the emergency exit door up here. Only exit, well, realistically, the only other way out of the airplane versus the main cabin door that we came in through. This is the one emergency exit on the airplane, and the emergency exit and the cabin door are the only ways in and out of the airplane. The refreshment center up here, you have a chart rack on the right side here. by the time that we go ahead and release the product, there will be books and charts and things like that in here. And on the other side, you have, this is the actual refreshment center for the passengers. We can open this up, and you have a coffee maker with your cups in there. That's the cabin. I'll take you to what you guys all really want to see. This is the front office up here, cockpit of the 441. The 441 from the factory had a few different instrumentation and autopilot options. There was a Sperry SPZ 500 AFCS system, the Cessna 1000 autopilot, which is basically just a souped-up version of the 800B that some of you might be familiar with from the 402. So if you have the 402 and you're proficient flying that airplane, this will be this autopilot will be a very easy transition for you. There were a number of different primary flight displays available. And Mark left this one all up to me to determine what we were going to do, so I opted for an interesting configuration. Perfectly realistic, they are out there, but an interesting configuration. We went with the Cessna 1000 autopilot flight control system with Collins primary flight display, primary flight instruments on the pilot's side. For those of you that want to fly the airplane and take advantage of its massive range, the 441 has a range with reserves of just under 2,000 nautical miles, which is absolutely fantastic for a 10-seat corporate turboprop. Beats many of the King Airs. In terms of overall performance, the 441 will pretty much outperform any King Air with the exception of the 350 and the 200 GTI. In its day, when it was produced, this airplane was built long before the King Air 350 was, and in its day, there wasn't a King Air that could touch this airplane. So it's the Conquest 2 is give you a solid 300 at altitude, give you a solid 300 knots every day of the week, 310 maybe on a good day. You can, if you take it up real high in the low 30s, you can get 2,000 nautical at 300 knots true airspeed pretty much every day of the week. So with that said, the airplane is RVSM'd. We did install RVSM altimeters. For realism's sake, I know the FAA doesn't ramp check anybody in the flight sim world, which is huge and awesome. But we decided to integrate RVSM altimeters just for those of you that want to take the airplane up into the 30s and be legal. So now I'll scoot over into the pilot seat here and I'll show you some of the features that we've implemented. So, we left the baggage doors open. Look at that. So here we are in the left seat of the 441. And just bear in mind, we still have a few little things to work out before we go ahead and release this for all of you. But this is, for the most part, just about a complete product. A couple little things we have to work out. I can tell you right now that airspeed indicator isn't going to stay like that. There's a new bitmap that we're going to throw in there, and a few other little things. I don't want to spoil too much of it. But anyway, so this is the front office. We have Collins flight instrumentation, a Collins attitude indicator, Collins HSI, a Collins dual needle RMI, Collins DME. Like I said, the RVSM altimeter up here. Your engine instrumentation is fairly typical. It's going to be a little different for those of you that are used to flying King Airs, but very, very easy adaptation and transition here. We have our torque gauges, EGT gauges, engine RPM gauges, fuel flow gauges. This is oil pressure, oil temp, and fuel quantity. Pressurization instrumentation is down here. The engine RPM gauges we opted to do a little differently. All of the airplanes out there, for the most part, in real life have been converted to Dash 10s, and part of the Dash 10 conversion was an RPM gauge with a digital readout. We opted to, in the interest of giving you the best Garrett engine simulation we could, given the limitations of Flight Simulator, which really, really doesn't jive with a Garrett engine. We worked around numerous things, and we have an awesome Garrett engine simulation for you. But one of the things we had to do was stick with the original Cessna RPM gauge instead of the digital one. So if there is any little inaccuracy in the entire airplane, it's these RPM gauges. I'll tell you that right now. Still perfectly functional, work exactly as they should. However, with a Dash 10 conversion, normally you'd have one that had a little digital readout as well as a manual needle. But that won't be too much of a concern for most of you. Okay, so what else? We also have a Collins radar altimeter, digital radar altimeter here. Autopilot mode selector down here. This is the 1000 series autopilot flight control system from Cessna. Your altitude selector and altitude alerter is right here. The autopilot control unit itself is down here on the pedestal next to the prop sync switch, and your pressurization controls are all down here on the bottom. Over on the side here, Mark Taylor did a fantastic job with this side panel over here. Absolutely right on with the real aircraft. So from the top up here, we have ignition override switches, which are used flight through rain, takeoff and landing, things like that. It's basically just a continuous ignition, like you'd find in a King Air or any other turboprop for that matter. These are your generator switches with on-off and momentary reset capability. Battery masters are here in the middle. These are your two start buttons, your unfeather left and right. That's used to get the prop back on the start locks in the event that you forget to engage the start locks on shutdown. We will be implementing the start lock feature for those of you that are going to ask that question, because I can see it coming a mile away. Also used to perform the NTS check on engine start, which is also simulated. NTS is the negative torque sensing system, which ensures that if in the event of an engine failure, instead, before you have a chance to feather the propeller, like let's say you get an engine failure immediately after takeoff, low altitude, terrain situation, you're worried about flying the airplane, and you have a couple of things you need to do, like worry about the trees, before you get that prop feathered. The NTS system is kind of like an auto feather system, except it takes it one step further. It almost does a little better than an auto feather. An NTS system will actually pitch the propeller automatically for 0 torque. So instead of just straight up feathering it, it pitches the propeller so that it windmills, but it windmills at 0 torque. And it does that until you manually feather it. So that switch in here and feather also used for testing the NTS system. 2 stop buttons here. King Air drivers, you guys are used to pulling those condition levers right down to the shutoff. Garrett engines, we don't do that. We have start buttons and stop buttons. We begin our flight and end our flight like a gentleman. We have our fuel boost controls here with main and auxiliary functions. Torque and EGT limiters, which spend most of their time in the auto position unless you have some sort of failure. Conquest has a plethora of de-ice systems. We have our surface boots, our windshield bleed air. Unlike the 402 that actually has a heated windshield, or the glass itself is actually heated by a heating element, the Conquest as a turboprop can take advantage of bleed air. So all of your windshield de-ice on both the left and right side is accomplished through the use of a bleed air tap right off the exhaust gas from the engine. And that's actually, if you look right here, just above the glare shield, that's what that duct that you'll see on both sides is. So if you get ice on the windshield, or you want to prevent ice on the windshield, that duct will blow hot air from the engines over the outside of the windshield, and not only will it remove ice, but it'll also prevent it from forming in the first place. Really, really useful in icing conditions. Prop heat left and right, stall vane heat, engine inlet heat, pitot-static heat, which is a really fancy term for pitot heat. This is your gyro inverter switch. There's a few systems in the airplane that will not run without the inverter on. The autopilot will not come on or engage. Autopilot or flight director will not engage without the inverter on. The attitude indicator won't work without the inverter. The torque meters will not work without the inverter. A couple other things. The avionics bus switches are right below that. And then up here on the side wall, also we have our exterior light controls. Landing lights, 3-position switch. Up lowers them and turns them on, and off is in the middle. And you push that switch down and that retracts them back up into the wing. Landing lights fold down and retract in and out of the bottom of the wing. Then we have taxi lights, nav, strobe, de-ice lights, all the things you're used to seeing in an airplane, except the beacon. Cessna, for whatever reason, did this weird thing in the 70s and 80s where they didn't put a rotating beacon on any of their airplanes. Not really sure why, what the logic is. My airplane in real life does not have a rotating beacon. And most twin Cessnas still flying around out there today have not, believe it or not, been upgraded with a rotating beacon. People will spend almost $1 million to do a -10 engine conversion on their Conquest, but they won't put a rotating beacon on it. Don't ask me. Don't really know. Recognition lights. This is an aftermarket modification, but we thought that we'd implement it just because we could. So you also have white wingtip recognition lights. And the fuel computer switches are up here. You can turn your fuel computers off in the event that you need a manual start. And your manual start switches are all right here. The Conquest is a hit it and forget mentality when it comes to starting. I'm going to do a startup video and show you guys just how accurate we've gotten this Garrett simulation in a few. So after I walk you through the rest of the cockpit, we'll pull the airplane out and I'll show you an engine startup and shutdown. But the Conquest is totally effortless to get started. As long as those condition levers over there are in the start and taxi position where they are now, and you perform your NTS check, you just tap that black button one time. You don't even have to hold it down. You just tap the black button one time, and you monitor the start, and the engine it just starts itself entirely, as long as you monitor it. Make sure that you don't get a hot start, a hung start, something like that. Otherwise, the engine is a totally automatic start procedure and a totally automated shutdown procedure. So very, very, very effortless in that aspect. The Conquest, like most other twin Cessnas, with the exception of those with tip tanks, has 2 fuel tanks, one on the left wing, one on the right wing. It's a ridiculously simple fuel system. The left tank feeds the left engine, and the right tank feeds the right engine. Pretty straightforward. So, as it were, there is no cross-feed system. There is, however, a a cross-burn system. And what that does is that's the switch down here, this knob here. This allows you, by rotating it left or right, this allows you to burn fuel out of the right wing with the left engine, or fuel out of the left wing with the right engine. So in the event you have an imbalance, that will allow you to cross-burn fuel using the opposite engine from the opposite tank, and you can even it out that way. What you cannot do is move fuel from one wing to another. But with this system, there would never really be any reason to do that. So, with that said, this is pretty much the walkthrough of the 441. I don't want to spoil everything for you. You'll have to check it out when you guys get it. But with that said, I will go ahead and pull the airplane out, and I'll do an engine startup and shutdown for you, just so you can take a look at the Garrett simulation. And also the custom sound set that will be included with this airplane. The Garretts have a very, very unique sound, and we really wanted to capture that for you guys. So we put a whole bunch of hours into really trying to whip up an awesome Garrett sound set, and I think it came out great. So let me get the airplane pulled outside. We'll go ahead and pull out the inlet and exhaust covers, get a set of chocks on the nose wheel, and we'll get the airplane fired up for you.
Let's go.